We're moving on to another section now, the next section, Earth to Space. And this has been organised yet again by Abigail, in the front row there, and also the director of ESRIC, who is Kathryn Hadler, who is just sitting over here. So first up on this section, we have Enrico Benetto, who is going to talk to us about the environmental sustainability for outer space, and he works at LIST, the Luxembourg Institute for Science and Technology.
Thank you very much. Hi, everybody. Good morning. So I'm very impressed. It's the first time I'm here at the Sustainable Resource Week. And I would say that 25 years ago, when I started working on sustainability assessment, I could not imagine that one day I would be on stage presenting and talking about sustainability in space. So it's really very exciting opportunity that I have today. So the point today that I would like to make is to share with you some thoughts about how to assess the sustainability of space operations. So introduce you with a conceptual framework that has already been developed also within ESA a few years ago, based on life cycle assessment, which is my main research activity since 25 years. Then looking at an example of how LCA could be used to assess the sustainability of space operations with an eco-design purpose. Looking a little bit more in detail at one of the key research challenges in this area, which is how to define areas of protection in space. How do we define what we want to protect in space? We have defined what we want to protect on Earth, but what do we want to protect in space? And finally, look at a little bit at the direct and indirect benefits that could stem from space operations. So as I was saying, LCA is a frame which has been defined by the ISO 1440 series. So basically, there are two main concepts here, if you're not familiar with the methodology. Looking at the whole life cycle, which is associated to a technology, not only the operation of the technology and the impact, what is generated during the operation of technology, but looking at the whole life cycle, production, and end of life, which is basically already a challenge when we talk about space operation, because we have infrastructure in space, and the end of life of such infrastructure is to some extent a question mark. And then to assess in part from a multi-criteria perspective. So not only looking to specific impacts, of course, carbon footprint and let's say the need for our society to decarbonize is clear for everybody, but there are also other type of impact that have to be looked at. So there is this scheme on the bottom where basically we have to inventory what is generated by the technology over the life cycle and transform this into environmental impacts that then represent and assess what we want to protect. These are the famous area of protection. So here, if we look at the space operation, there are already a number of questions, because first, these type of assessments are done to compare alternatives. Eco-design is typically an example. You compare different configuration of fully space operation, hybrid operation, Earth and space, or so that's already a point how to define a good function, a good basis for comparison, what we call a functional unit, because we need to compare things and technology that do the same thing. Otherwise, we are comparing apples with pears, so it's not the same. And that's already quite a huge question in the space. Then data, because there is lack of data. For example, we don't have data on some specific materials that are used in the space operations. So data about how they are produced, what are the emissions related to their operation or their use, and then how to assess impacts. So we'll see later. So one example that I was mentioning that I found in the literature is the assessment that was done to compare different, let's say, two alternatives related to the Sentinel-3 mission. So one, let's say, conventional one and one green one. It basically included a replacement of the propellant, replacement of hydrogen. And so that's the type of results that we can get from this type of assessment. So looking what are the main phases of the life cycle of the two options that are contributed to the environmental impacts. So here we see, for example, that production and design phase are very much important, contribute to a lot of categories, especially because of, as usual, electricity and natural gas consumption related to the production phases or to the materials. Meaning this is related to resources or use of resources to produce the materials that are needed for the space operation. Then we see also the contribution, for example, of the utilization phase, of course. That's in the gray, dark gray part. We can see the importance, for example, of the data servers and all the electricity and energy which is consumed to sustain and to basically to operate those missions. And then the comparison, green versus blue one. So comparing the alternatives overall, considering all the impacts together. And we can see, for example, that the replacement of the propellant does not provide significant advantages in terms of environmental impact on Earth, so the conventional categories that we use, but has a significant impact if we add space debris, or let's say the orbital space as an area of protection. And that's the next point. So how to then enlarge what we assess, the scope of our assessment, considering that space is something which is outside Earth, so it's by definition. So it's outside the scope, the boundaries of what we have assessed so far. That's an interesting development where authors have tried to assess the occupation of orbital space and assess two consequences of this occupation. So what we call usually in LCA a consumptive use of orbital space, of a space in general, in this case orbital space, or a degradative use. So when we talk about consumptive use, we say that, okay, we are occupying space with a system, with a technology, and by the fact that we are occupying space, we are in competition with others that want also to occupy the space. So the competition for space, competition for land on Earth, competition for space on space. And then we can, by occupying, by the fact that we occupy, we use it, we create a deficit of space for future use of that space. Okay, this is the consumptive use. The degradative use, there are two aspects of that. Since the space is already degraded because of the existence of space debris, this can have an effect, an impact on our technology, on the operation of our technology. So it can damage the operation of our technology, and that's the first one. And then the technology itself, once in space, can worsen the situation of space debris, because it can generate space debris, and so can have an effect on other technologies that will then occupy and use the space. So these two types of effects create a potential loss of value for society that can be an additional value that we want to protect, and that has to be included in the assessment of a technology when compared to another technology fully on space or hybrid. So the same reasoning could be done for impact of acoustic waves on ionosphere, for cultural heritage. There is cultural heritage on space, on the moon, so that could be an area of protection. And I added the last one this morning, but I couldn't upload it, of course, ozone depletion, because it's well known that, let's say, the launch operation, following the launch operation, we introduce, let's say, specific substances in the upper stratosphere, and this has a direct impact of ozone, so on Earth, on the, let's say, impact on condition on Earth. So I try to look at all this. So you've seen there are challenges in terms of data, in terms of how we do the calculations, really in terms of data that have to be collected, challenge in terms of what we characterize, but then why we should use sustainability assessment in general to assess space operations. So, and there is a mix of levels. So I try to design these metrics, because if we separate activities in the space, activities on Earth, and then we look at specific components of such an assessment, we are talking about resources, we are talking about operations over the life cycles, operation of technologies, and then pollutant emissions that are generated by those technologies. So we have these 6 areas. So if you talk about resources in outer space, of course, the goal would be, for example, to compare in situ resource utilization versus a delivery of resources from Earth. So we are talking about space missions and comparing different alternatives, or how we gather the resources that they will be used by those operational space. And that's one type of comparison that could be run by such an assessment. If we're talking activities on Earth, space technologies can, of course, add a benefit, can generate a benefit on Earth in terms of additional prospection or better prospection, better extraction of resources on Earth, and this versus market alternative technology on Earth that could be developed. So that's a benefit that space mission could have on Earth. When you talk about operations, like Sentinel-3, of course, and outer space comparing design alternatives, including the end of life, different way of designing those missions. And on Earth, since the technology developed in the space could then be reused on Earth for Earth, let's say, purposes, then compare conventional technology that we are already using on Earth that are only developed on Earth to the new ones that will be, let's say, transferred from what we learn from space. And that's also a nice comparison that could be done. Then finally, if you look at the pollutants, the same, let's say, if we are on space, comparing different impacts generated on space by the operation. So you have seen, for example, the one on space debris. So space debris and the other categories that I mentioned. Here there is a lot of work to be done. And then on Earth, so as I said, operational space, ozone depletion is an example. Operational space has also an effect on Earth, on the impacts on the air protection on Earth. So ozone is an example. Another example is, for example, impact of aluminum oxides that are generated during launch that are not characterized so far, and they should be. So these are 6 areas, very promising areas of research and innovation from my perspective when sustainability assessment is at stake. So, as a take-home message, maybe it's trivial for you, maybe not, but for me it was, these are important points. So first, we talk about environmental sustainability and sustainability in general. This shall be assessment, for the type of, with a quantitative life cycle multi-criteria approach. So it has to be quantitative life cycle and consider different areas of protection, different environmental impacts. Property change of functional unit, data gaps, and missing area of protection are priority areas. I've listed a few. But then there are a few promising areas of investigation when it comes to assess the indirect impact of space operation, indirect benefits of space operation on Earth that are worth investigating. And yeah, I will be pleased to start this with you, with some of you, one interest, and I'm sure that I will have enough to do until we retire. Thank you very much.
Thanks, Enrico. I can't see any questions in the forum. You have to be quick to get your questions in. But I do have a question for you, because I think this is an absolutely fascinating topic. And I think it's absolutely the right time to be thinking about life cycle assessment for space resources. But my understanding of LCA techniques, is that the quality of the output very much depends on the quality of the input data. And obviously with a lot of space resources systems, then we don't have a lot of input data. So how do we manage the implementation of LCA techniques when we have quite limited quality data in the first place?
Yes, indeed. Garbage in, garbage out. That's indeed. It's always the case. It's the case also for technologies on Earth, for new materials. When we develop, let's say, new material, new technology, we have to scale up operation from the lab. That's the usual, let's say, problem that we have. So what we do is through cooperation, through simulation. Simulation is also very, very interesting approach to generate data. So there are common techniques for that. The point is that we have to decide if we stop because we don't have data, or we use the data that we have and assess the uncertainty and get still relevant results with the uncertainty associated. So I would opt for the second one, because otherwise we don't progress.
Absolutely, I couldn't agree more. Thank you very much.
Thank you.
Thank you very much. And our next speaker is going to be Ana Fernandez Iglesias, who's going to talk to us about the circular economy. She's a circular economy expert, and the title is Circular Economy on the Mining Industry, and she's joining us online. Ah, yes, you're there. Thank you.
Hello, can you hear me well? Can you please confirm you can hear me well?
Yes, we can hear you very well.
Okay, excellent, good. So I'm not seeing yeah, okay, thank you. Well, thank you very much for inviting me. I'm really pleased to be part of this. I'm excited, I'm learning new things, and I hope that I can give some insight about circularity for mining. So next, please. Correct. consider light moving. Okay, yeah, great. Just to introduce myself, because I'm really from this industry. My name is Ana Fernandez. I'm based in Spain. I'm a chemical engineer, and I also hold a PhD in mining waste management. So those are basically my passions, the ones you can see there: sustainability, circular economy, and always around R&D and industry innovation. Okay. I'm also alumni and mentor in the Ellen MacArthur Foundation, which is probably the best resource for learning about circular economy, by the way. And next, please. Also, I have to say that I have absolutely nothing to do with the space. So it's totally out of my comfort zone. I love visiting other worlds, but they are all here in this planet Earth, underwater. So sorry if you use any term that sounds a little bit strange. Okay, thank you. Next, please. Okay, so yeah, I'm here to talk about mining. Basically, I work for the mining industry. In fact, I work in R&D for a big steel and mining company. And people tend to ask me, how can you work in mining if you are supporting sustainability? Right? If you are so passionate about the concept of circular economy, how can you work extracting finite resources? Okay, because circular economy, as you know, really promotes an economical growth independent from resources extraction. So, be honest, most of the people sees first the negative aspects of mining, impacts on the Earth's surface, on water, on air, and of course they are there, and the industry works very hard to reduce them, believe me, because I work in this field. And next, please. The truth is that we don't have many good examples of former mines that have left a legacy instead of liability. This is a wonderful case example, Eden project. You can visit it in Cornwall, UK. It's a former mine that now has turned into a huge botanical garden and promotes education and knowledge. Next, please. Okay, so the truth is that materials and sustainability are really linked. Here you can see, I don't know how close you can see it in the ones that here in person, but you have a great part from the website Elements, which is great, by the way. If you don't know it, you should visit it. And you can see all the metals that all the energy sources need for the green transition. Okay, next. So what they claim here is that even though green energy comes from renewable sources like wind or sun, they require massive amounts of finite resources to make it all work, and that's a reality. To get off fossil fuels, we will need those massive amounts of metals and minerals mainly. Next. And many people, when I talk about this, they talk me about circularity. Okay? Like, okay, if you work in circular economy, why don't we recycle this? Why do we have to extract it? And the answer is very clear. We don't have the capability to recycle all the metals and minerals today. We have not designed in the past the product so that they are circular, so it's very complicated to recycle many things. And also recycling industry is an industry by itself, and it has impact. It's a process that has impact on the environment as well. Okay, so that's the first answer. And the second one is that we don't have enough, to be honest. We don't have enough materials for that green revolution that we are aiming for. Next one. If you think about offshore windmills, which is probably one of the best solutions because it doesn't have the impact that it has on Earth and so on, we think about this, but we sometimes forget what this means. Next. This is a great tweet that I found recently, which is a submarine cable of an offshore wind turbine. So you can see the copper there. They require 50 kilograms per meter of copper to feed this system of energy. So it's clear that we need many, many resources, and mining is inherent to that green transition. Next. So there is also this photo going around by the great photographer Bill Marsh. You can see there. I recommend you to visit his site because he makes an analysis of, okay, mining, what it means, and what we get, and what is left. Okay, so you can see here what it simulates to be is a former copper mine, and what you have in the middle is the copper ball that would mean the resources that we have extracted, okay, the metal. But what happens with all the material that was there? What is the rest of the material that we see in that ball? Okay, next. And in this graph about the resources and the tailings, Reed Arendal explains it very well. So those of you who are not familiar with mining, we basically blast the mines and we create stockpiles. And these stockpiles are led to the process where we crush it. So we spend a lot of energy really in crushing and making the material finer. And then it goes to the mill. And in an average mine, for more or less 1,750 tons of concentrate, we generate 200,000 of slurry tailings. Next one. Tailings, what they are is a crushed waste material, very finely crushed, mixed with water and chemicals, because most of the mining processes require this. Flotation or transport with water, magnetic flotation, whatever. But in most cases, what we do is we mix this very fine material with the water and the chemicals. And again, an average mine, of course, each mine is totally different, but for 1 ton of concentrate, we generate 1,000 tons of slurry. Next. And what do we do with this slurry? Okay, and the answer is, at the moment, not much, to be honest. You can see here a great graph by John Engels. So you see the pit up there, the processing facility, and then what we see in the colors is the tailings dam. That's where we store all this material and we let it settle. And we build a tailings dam with their own material from the mine. It's not concrete tailings dam. Okay, so how does it look in reality? Let's see the next one. We're talking about massive structures here, depending on the mine, of course. This is from a Rio Tinto facility, but we store those tailings, those fine crushed waste material, organic compounds for flotation, water, and so on, and we just keep it there. Next. The industry is really working hard to develop solutions so that this storage is less risky and takes less volume. Okay, so, for example, in here you can see the difference between the with the water and intensified or the water tailings in the other part. Next. And again, I have not been in other planets, but believe me, sometimes when you visit tailings dam, it's all you can see in the horizon. So there are very big, massive facilities like this one in Australia. Next. And in fact, NASA helps us see some of the impact of these tailings dams. In this case, this is the Mount Poly tailings dam in Canada, in British Columbia, I think. So we could see with NASA that the dam broke and there was some impact on the water body close to it. Next. Okay, so how big is this problem, really? The Global Tailings Review estimates that there are 8,500 facilities of tailings on planet Earth. So that means 282 billion tons of material, all in active, inactive, and the closest storage facilities. And that means more or less, if you can see that cube, a cube that could be a 6-kilometer height, the size of Manhattan, more than the size of Manhattan. So this is a huge, huge problem, and it keeps growing because we keep mining. Next. It's not getting any better for 3 main reasons that I will explain now. Next, please. It's not only that we are mining more, there is an increased demand and we will have more extractions in the future, but also the fact that the good mines, we have already exploited them. Now the good deposits are in more depth, so we are now approaching poor ore deposits. So that means that the waste to ore ratio is going to be higher. We're going to create more waste. In fact, we are also researching on how to extract these poor deposits. So the technology for beneficiation, for processing the concentrate is evolving as well. So that means that we are now able to extract ore with a higher waste ratio than we did in the past. Next. for all those reasons, it's an ever-growing problem. We will never generate less mining waste, than we are generating today. And this is a totally different news, but I hope that someone can make the connection, okay? This is a piece of news that we will see more and more about the crisis of sand. We are approaching a moment in which the finite resources of sand on Earth are also going through a crisis. This started with sand before the pandemic, then it was a little bit stopped, but now it's coming back. And at the end, we have to think that many of the material that we have, for example, in those tailings dams, is very similar to the sand. And the big question is, okay, why aren't we using those resources? How circular are we in mining? Okay, because when we design a mine today, we are not having into account that waste. We are just considering that we are going to treat it in the safest way. We're going to store it. We are going to make it safe. But we are not thinking in most of the cases, what are we going to do with it? Okay, next. We have to stop looking at the tailings dam as take for granted in our mining operations, and we have to start thinking of those resources in a different way. We have to start linking the needs of other industries with the mining industry. And it's true that we are limited right now because circularity is very regional, let's say. You can transport your waste to a given number of kilometers. And it's true that many of the mining sites are in remote areas, but as we are approaching a different economy based on hydrogen, for example, we will not have those CO2 emissions when we transport the material. So we have to start thinking about what will we do with all the materials that we have in the mines and not only the main ore. Next. At the end, this is one of the best definitions, in my opinion, about circularity, which is design out waste. That means that we have to start taking the word waste out of the equation and start thinking as designers of the future facilities like waste was not an option. Next. This is a statement of products. Up to 80% of environmental impact is determined during design phase, but I have no idea what the impact is in the case of a mining facility. But definitely we have to start thinking about designing the mines, and I hope that in other planets that will be already taken into account, getting about waste. We have a full deposit, we have to take advantage of everything. Different applications, that's true, but we have to integrate everything in our design mindset from the beginning. Next. Next, please. Yeah, thank you. This is not a problem. I wanted this slide to be as black as it is, because the truth is that I cannot show many cases of real mines that have turned their waste into a byproduct or into a product or secondary raw material for another industry. Of course, there are cases of mines that are starting to remine their tailings, okay? But the truth is that we don't have many examples. That means that a lot of research is needed, a change in mindset. We have to start thinking of the circularity possibilities in mining and design out waste and start thinking in a global perspective about the resources we have. Thank you very much.
Thank you very much, Anna. Can you hear me?
Yes.
Excellent. Yeah. Thanks for a really excellent talk and actually a real reality check on the situation that we find ourselves on Earth. The Eden Project actually is about half an hour away from my old home in the UK. It is genuinely a beautiful place to visit if you're ever in Cornwall. But what I would like to say about the issues of dealing with mine waste. We spend a lot of time, there's a lot of research, a lot of activity in the field of managing the vast amount of tailings and mine waste that we've produced certainly over the last few decades. Mm-hmm. And actually we're trying to solve a problem after it's happened, which is exactly the point with space resources. If you were to start mining on Earth again, what would be what would be one of the first things that you would change? Because this is the opportunity we have in space. So if we were going to do this again on Earth, what would you do differently?
I think that the statement about design of waste really symbolizes everything, because we have done that. We are doing it with CO2 now, but it has taken us decades to be convinced that we need to take CO2 out of the equation. So if the mindset is that whenever you start a new operation, you need to find an application for all the material that you have there, and stop thinking about this is waste and this is my product, then would help us to, of course, do things in a better way. We will not be able to take advantage of almost 100% of the waste, but definitely we have lots of sand sitting in tailings dam, and now we have sand mafias in other parts of the world extracting resources. So we need to make those links. I would start by that, by having a global vision and stop thinking about this is my waste and this is my ore.
Yes, I think you're absolutely right that we start off with the point that we try and make use of all streams rather than just producing these huge volumes of waste and then having to deal with those consequences later on. Thank you very much for your talk, Anna.
I have one question. If she could just stay online for one more question. Can you hear me?
Yes.
We do have one question that I can see on the chat. Apologies for bringing my laptop up, but I'm not getting the questions through my phone. It's from Christophe Bosquillon, who says, very nice presentation and reality check, and writes, regarding sand, desert sand, it isn't really usable due to the lack of cohesiveness between the particles. It makes for poor construction material, with eroding beaches letting salty water into arable lands. This is really a crisis in the making. Would you agree?
Yeah, definitely. And I think we will see it. You will see more and more news about the lack of resources. There are mafias extracting sand in beaches, in areas where you don't have an official operation, an extraction place, a license, and we will see it. And well, having seen lots of tailings during my professional life, I can bet that many facilities would be something useful, definitely.
Thank you so much again for the lovely talk, and thank you everybody for your wonderful talks for this first session this morning. And to round it all off, please welcome to the stage one of the organisers, along with Kathryn Hadler, who is of course Abigail Calzada Diaz, who many of you will know.
Hello, hello. Thank you very much, Lisa, and welcome. And I hope that you are enjoying so far this morning. So yeah, I'm going to, it was introduced briefly in the morning by Pierre Alexis in the Euro2Moon talk, but I'm going to introduce to you or make like a presentation of the Euro2Moon working group on sustainability, that is sustainability, environmental and social responsibility. So I would like to thank first all the speakers that were before me, because they make my presentation much easier, because they already tackled some points that we think that they are very important to start addressing so early and right now. And then it's like you will understand more easily why we are creating this group right now and what the importance of that. So yeah, the objectives of this group is to perform comprehensive studies on the environmental and social impacts of lunar resources utilization activities, but also to study and promote circularity implementation among the space resources industry. And finally, but not least, is like to provide recommendations to the industry and regulators on measures to prevent, reduce, and control the identified adverse effects. During Enrico's talk, he already addressed that the importance of checking the impacts that are having of all the activities that we do, the impacts on the lunar surface, the impact on space, and also the impacts that they can cause on the moon. So that is one topic that we would like to address. But also we want to do some risk analysis that we cannot do if we don't know the impacts that actually we are causing. So we want to do this analysis on the mitigation and the avoidance of undesired consequences. Also, as Anna was saying, it's important to start early, not only early in time, as also Carlos pointed out in his presentation, that we need to start as soon as possible, but also early in our design phase. We need to understand how we can design to have better, more efficient way of doing operations, but also to reduce these unwanted impacts as well. And finally, also, it's like we would like to contribute to the UN Sustainable Development Goals, because those are, I mean, we are thinking about using space resources and doing all this work on the moon, and sometimes we forget that many of these operations, or at least some of the operations, and some of the work that we are doing it here on Earth, and we have to do it just to improve for real the quality of life of the people here on Earth, but also the quality of the environmental around us. So that because the space resource industry here in Europe and also ESRIC, we are committed to actually work on sustainability and actually explain that sustainability really means something. It's not just a word that we use here and there, but actually we need to take this very seriously. We are creating this working group. So as I just wanted to do a presentation, I would like that all the companies based especially in any ESA nation, that who is interested in joining us and joining in this big challenge that we have ahead of us, to join Euro2Moon, to speak with any of the members that are present here in this conference, like Pierre Alexis, Carlos, or myself, come to us and become a member of Euro2Moon, because for us it's really important that we need to fully understand the implications of our actions to develop strategies to mitigate or even avoid completely and harmful impacts. So with that, I just want a few minutes from your time. Now there are some coffee waiting for us. So thank you very much, and I hope you continue enjoying the rest of the Space Resource Week. Thank you very much.
Thank you, Abigail. And you'll notice that we are shockingly early, and that's because we lost a talk. However, because we're early, I'm going to be quite strict. We still have a 25-minute coffee break starting very, very soon, but 25 minutes. So I would like everybody back in seats for 10:15, if that's okay. So that gives us a 10-minute head start for those online as well. We'll start at, 11:15. I've lost an hour. 11:15 back here in the room. Julia Samaka has asked online, are the sessions recorded? Yes, they are. And all of the slides will be available afterwards as well. Thank you.